we said that in the Newton's first law of motion that the body which is at rest will remain at rest if it's not acted upon by any external force, or the body which is in uniform motion will remain in that uniform motion if it's not acted upon by any external force. But sometimes what happens is many forces acts on the body simultaneously, and the body is not showing any kind of change in state of rest or uniform motions. How? For that I'll give you an example. Suppose say this is a book, okay, and this is a book, and you apply two forces from two opposite sides, okay, from this side and this side, okay, in the opposite direction. These two forces are acts on the book at the same time in the opposite direction, from the opposite directions, okay. And suppose say if these two forces are having same magnitude, suppose this is also 10 Newton and this is also 10 Newton, then these two forces cannot move this body either side, this side or this side. This body will move nowhere, it will remain at that rest. So here we have applied the forces, right? Here we have applied the forces, even then, okay, the body is not moving. So this type of forces are called what? Balanced force. Here these two forces cancel each other. So here the net effective force is 0. Net resultant force is 0. So this type of forces are called what? Balanced force. Here these two forces balance each other. I'll give one more example. Suppose the vehicle is moving uniformly in the with the uniform velocity. Suppose the body is moving in this direction in a straight line, not changing its direction, okay, and with the speed of 10 km/h, the same speed. That means the motion is uniform motion. The body is moving with the uniform velocity. And in this case, okay, if I say that, okay, two forces are applied on this moving vehicle, okay, from two opposite sides, okay, two opposite sides, from this side and this side, okay, one is pushing back and one is pulling back, okay, in the same opposite direction, okay, in the opposite directions, from the opposite direction, okay, in the same line. And suppose that these two forces happens to be having same magnitude. Suppose that this is also 10 Newton and this is also 10 Newton. Then in this case, these two forces will not, brings any change instead of uniform motions. These two forces will cancel each other, and this vehicle will move with the same uniform motion. That means it will move in the same straight line with the same speed. You will not find any change in change in directions, or also in any change in its speed. It will move with the same speed and the same straight line. But once you apply with the different forces, like suppose in this case, suppose say 15 Newton, then the body will move in the direction of the direction of the greater force. It will move in this direction. And here what happens? Suppose say this force is 15, then as you're trying to push here, okay, here you'll find that, okay, body is moving with a slower velocity or slower speed. So here you'll find that, okay, there is change in uniform motions. So this type of forces, okay, are called what? Unbalanced force or effective force. Effective forces, unbalanced forces or effective forces. So that is why, okay, looking at these examples, okay, the situation, okay, we need to redefine our Newton's first law of motion. We just said that, okay, any external force. Now we need to say that, okay, the body which is at rest will remain at rest, and the body which is in uniform motion will remain in motion unless it is acted upon by external. It's not just external, but it is what? External effective or unbalanced forces. Unbalanced forces. If you just say forces, okay, sometimes what happens? So you apply the forces, but that force is not able to bring any change instead of motion, or instead of instead of rest, or instead of uniform motion. So here we have to be precise, to be perfect, to be correct, okay, we have to say here what? Unbalanced forces or effective forces. Unbalanced forces or effective forces, or we can say the net forces also. So here it is said that, okay, thus when a number of forces acting at the same time on a body do not produce any acceleration in the body, the body continues to be in state of rest or uniform motions in a straight line, since there is no net resultant force. Such forces are called system of balanced forces. So if the forces are balanced forces, because they are equal from all sides, okay, they are cancel each other, okay, then it will not bring any it will not show any kind of what acceleration in the body. That means body which is at rest will remain at rest, and the body which is in uniform motion will remain in uniform motion. Uniform motions.